Hey, this is Mr. Aiden. This is Unit 8 Applications of Integration, and we're going to be doing the area between the curve and the x-axis. So we're going to start off with a really easy problem first. Let's take a look at this curve right here. We have y equals 2x, and let's say we're taking a look at the area underneath this guy from 0 all the way to 4, okay, which means I'm going to take the area of this big triangle. How do I find the area of this big triangle? Is I have 1/2 base times height. 4 times 8 is 32 divided by 2, and that is 16. So the entire area, and we could say from 0 to 4, of this function 2x dx is equal to 16. Now, what are we really doing here? Is we're taking the area or the integral of this guy. We know how to take the area of a triangle. If it's a curve, that's what we're going to use our integral for. But what are we really doing is, inside this function right here, we're really going from 0 to 4 of this function right here. I'm going to call him f of x. And I'm going to call this function right down here, this y equals 0, I'm going to call this g of x, if that's okay. And so we have f of x minus g of x. And so the area on the top underneath this green minus the area under this red, which obviously is 0, ends up giving me 16. So this is going to help us out a little bit. Let's say we're going to find the area underneath this green curve of y equals 2x. Remember, we're going to call this f of x. And we're going to call this guy y equals 1. I'm going to do this in red right here. Y equals 1. I'm going to call this g of x. And I want to find out the area underneath here. So let's think about what this is saying here. Is I'm going to take the area from 1/2, obviously, all the way to 4, those are going to be my intervals, of 2x dx. Okay, now there's another way to look at this. Another way to look at this, now, let's say I do that. Let's say I do that, and I do 1/2 base times height. So my base is 3.5 times my height goes from 1 to 8. That's 7 divided by 2. And that gives me 49 over 4 is the area from here to here, all this area in between there, okay? And so that is my area there. Now let's think about this in a different fashion. Let's take a look at this area underneath all of this from 0 to 4, of my f of x dx. And I'm going to take away my area from 0 to 4 of my g of x dx. Okay, so what I did was I took the area of this green guy, which was 16, if you remember, and now I have the area of this red guy right here. Okay, this area of this red guy, and you can see I have this rectangle right here, this 3.5 times 1, that's 3.5, plus this little guy right here, that's 1/4, 0.25. And if I take 16 minus 3.75, I end up getting 49 over 4, the same area. Because think about it. This area, and let me do this with a little bit of a marker here. This area right here, from here to here, all this area in here, this area is really this whole green area right here. Take away this red area right here. And what's left is this black area, which is 49 over 4. And so you can see how there are many different ways to take a look at this problem. We're taking a look at our integral from a to b of my intervals of one function. This is I'm going to call this the upper function, minus g of x, which was the lower function. Now, if this is the x-axis, this is just equal to 0, isn't it? dx. And so that would end up giving me the area underneath. So here we're taking a look at the area under the curve of this function f of x equals x squared from 1 to 4. So we're going from 1 to 4. We're taking a look at this area underneath. So we're taking a look at this area all the way from here to here and all that area in between. So we're going to go from 1 to 4 of x squared. And keep in mind, we're really going to the x-axis here. We're really going all the way down here to y equals 0. So we're really going minus 0 dx, okay? Now, we don't have to put that 0 in there because that doesn't have any area underneath. And if you do this in your calculator, you end up getting 21 for this full area. Now, let's say we want to change this value. We want to take a look at the area underneath from here to y equals 2. So this guy right here, y equals 2. All right, so we want to know this area underneath here, okay? Which there's a bunch of different, there's other ways to do this, isn't there? To find out this area underneath here. So one way is we take our upper function minus our lower function, okay? So the area underneath all of this guy is from 1 to 4 of my x squared minus my 2. My upper function here is x squared. My lower function is 2 with respect to dx, and we end up getting 15 here, 15. So this ends up giving me an area of 15 right here. Now, are there other ways to do this? You better believe it. We could also take a look from 1.5 to 4, right? And we could take a look at the area underneath this x squared, take out this area underneath right here. If we do this, if we do 1.5 to 4 of x squared dx, okay, that ends up giving me, if we do that in our calculator, 20.283. And think about right here, y equals 2. We have 1.5 all the way to 4. So 4 minus 1.5. We have a little rectangle here times 2. Ends up giving me 5. We take away 5 right here. And we end up getting approximately 15 again. Okay, now that is giving me this weird curve right here. And at 1.5, we don't get exactly 2. We get 9/4, which would account for this 0.283 right there. So if you can see, there's many different ways to take a look at this function. And all we have to do, like let's say we want to know the area underneath x squared and y equals 6. We want to know just this area right here. The easiest way to do this is we could go from 0 to 4 of x squared minus 6 dx. And what that's giving me is, it's giving me my upper function from 0 to 4, so it's giving me this whole area underneath. It's giving me this 6 and his area underneath from 0 to 4. It's taking them away, it's subtracting them, and leaving me left with just this area up here. Okay. Let's take a look at this one. We want to find the area under the curve of cosine of x. Here's my cosine of x graph, and we're going from 0 to pi over 2. 0 to pi over 2. Now, this is a positive area right here. So we're going to go from 0 to pi over 2 of cosine of x dx, which ends up giving me sine of x, and we're going from pi over 2 minus 0. Sine of pi over 2 is 1 minus sine of 0, which is 0, which ends up giving me a 1, which means his area is equal to 1. Now, what would happen if my area is going from pi over 2 to 3 pi over 2? So pi over 2 to 3 pi over 2 of cosine of x dx. Well, that will give me sine of x from 3 pi over 2 to pi over 2. What is, let me write this a little clearer, 3 pi over 2. So what's sine of 3 pi over 2? Sine of 3 pi over 2 is negative 1. Minus sine of pi over 2 is 1. Negative 1 minus 1 is negative 2. So my area under here is negative 2. Again, what am I doing in each function? I'm going with respect to the x-axis right here. And so what is really happening is I'm doing the integral of cosine of x, which is this upper function, minus 0. What did we do over here is I could go from 0 minus this upper function minus the lower function. That would give me 2 right there. So, but it's below the axis, so we get negative 2. So I know we've gone a little bit ahead in taking a look at the area between a curve and another function, but between a curve and the x-axis, you're just minusing 0. Have a good day.